substituting in place of x, that value we can find the value. Okay. So this is called as functional value. Whenever it is given like this, limit extends to 1, f of x. Okay. So in place of f of x, if you think it is limit extends to 1, our given functional value x square plus 1. Okay. Here also the main concept, how you are substituting x value as 1. Here also x is tending to 1. This symbol is there, no? Like this arrow mark. It is called as tends to or approaches. Okay. So this represents tends to or approaches. Tends to 1 means x is moving to 1 or x is approaching to 1. So when x is approaching to 1, what is this value? F of x, x square plus 1 is approaching to which value? That is the main concept of it. Hello? Someone is disturbing the class, mute the phone.
Sai Jansi.
Hello. Okay. So here if you write in place of limit extends to 1 x square plus 1, it is also same as the functional value how we have substituted the 1. That means x value is tending to 1. In simpler form, we can substitute here same limit value is 1. So 1 plus 1 equals to 2. This is called as limit value. Okay. So functional value is for the function you are substituting the value as 1. Whatever the value you are getting, that is called as function value. If it is a limit in that function, if you are substituting this is called as a limit extends to 1. So when you substitute whatever the value is you are getting, that is called as limit value. So these two almost the concepts are same. But why the concept of the limit is introduced? Because some functions are there, whenever you substitute the limit value in that, they will be in the form of indeterminate form or undefined form. Okay, these type of forms you will get. So the forms will be like this. So if you take limit extends to 1, x square minus 1 by x minus 1. If the function is like this, so only the functions will be not in a simpler form. No, they will be somewhat complicated functions also will be there. So for those functions, direct substituting of the limit value is not applicable. So in such cases, so to solve those problems, the concept of the main limits has been introduced. Okay. So limit extends to 1 x square minus 1. X minus 1 means that is you are substituting in place of x 1 minus 1 minus 1. So it is 0 by 0 form. Okay. If here 2x is there, so what you'll write here, you will get 2 minus 1. So it will be 1. So it is equals to the value is 0 here. Okay. You got the limit value as 0. Why? Because 0 is there in the denominator. You have one number is there. So you have the value for this one. That is 0 by 1 is 0. But when it is 1 minus 1, you will get it as 0 by 0. This, whatever the form is there, this form is called as indeterminate, means we can't determine the value. Or it is called as undefined form. Okay. So whenever the function, after substituting the limit value, if they are getting the answer as a indeterminate form or undefined form, so such type of problems can be solved with the help of the concept of the limit. Okay. So that is the main concept of introducing the limit here. So if you know the concept of the limit, from that you can know the continuity, and from that you can know the differentiability. So already in intermediate you have seen the differentiability of the functions. So some functions you have, that is d by dx equals to 1, d by dx of x square is equal to 2x, or sin x equals to cos x. So those are all, whatever the formulas you have there, those they have been got from the derivability of the function. So derivability is related with the limit is related with the continuity. Okay, here. So, and one more thing is here, undeterminate form and or undefined forms will be in the form of 0 by 0 or infinity by infinity, or 1 to the power of infinity, or infinity to the power of 0, infinity minus infinity, like this. Different forms will be there. So such type of any function, after substituting the value, limit value, if you're getting in this, then we can use the limit concept for this one. Okay, the main here, for solving the problems, you will have the working rule will be there for solving the problem of the limit. But if you see main standard, one of the definitions will be there now. So the definition is that any subset, you will take here, whatever the set is there, that set is the real numbers. And you know that the real numbers, it is represented as a capital R. So from the real numbers, capital R will take one of the subset, that is S is any subset. It is always, that is S is the set which is subset or equals to R. So from this set, we are taking the element A here. And also here, the from the definition, you have two elements are there. Those are, this is the epsilon and this is the delta. Okay, epsilon and this is delta. And these epsilon and delta are always greater than 0, means they are the positive integers, and these two are called as arbitrary constants. Arbitrary in the sense we are imagining them. Okay, epsilon and delta always greater than 0. These are the integers, and these are the arbitrary constants. They are included in the definition of the limit, that is SC subset or equals to R, such that you will have for epsilon greater than 0, there exists delta greater than 0, such that 0 less than mod x minus a less than delta. So for each, that is the mod of f of x minus L is less than epsilon. Okay, so in between of this, some sentences will be there that you have in the textbook. The definition is there. So the main thing is, whenever epsilon is greater than 0, there exists small delta, it is greater than 0, such that this condition is satisfied. That is 0 less than mod x minus a less than delta, such that mod x f of x minus L less than epsilon. This is the definition of the limit. This is the main definition. So from this only, you will get the concept of solving the problems. So here, if this is satisfied, this condition is satisfied, means we'll write here like this. Limit is exactly x tends to a, f of x equals to L. So this is the main formula of finding the limit. That is, whenever limit x is tending to a, f of x tends to L. When the condition is 0 less than mod x minus a less than delta, and this one. Okay, so even limit you will write like this, f of x tends to L when x tends to a. When x tends to a, f of x tends to L. Okay, so here, so this concept, from this you have, whenever we'll solve the problems for the theorems, this concept is used, that is 0 less than mod of that one. But for solving the problems, we'll go to the finding the LHL and RHL. Okay, so whenever x is tending to L, f of x is tending to L. That means we have the concept of LHL and RHL. LHL is the left hand limit and also RHL is the right hand limit. What will happen means, for some problem, when you substitute the A value directly, you can get the answer. But some values you may not get the answers. So for such problems, we'll see the approximation. When x is that is approaching to A, the f of x value is approaching to some value. So in that cases, if you see here x value equals to A and here f of x equals to L. So these values, some values you can take from this side and some values you can take like this side. Here also same, like this and also like this. So they approach from LHL side and also RHL side, and they meet at the point x equals to A. And here whatever the answer is there, that answer also, it will approach from this side and it will meet at f of x equals to L. And here also like this. These two concepts will depend on delta value. Okay, delta value you can take 0.1, you can take 0.001, you can take 0.0001, like this. When you substitute delta value as 0.1 in any function, before function we have seen no, x square minus 1 by x minus 1. So you will get one value here. If you will take delta value this one, you will get one value here. Means if we'll take here x is tending to 1, no? So here left hand side means it will be 0.9, here 0.99, 0.999, here 0.999, like this values will get. These values depend on taking delta. That is, whatever the delta value will take, that value depends on this one. So this is, if we'll take any problem like this, x tends to 1, x square plus 1. Means if we'll substitute limit value, what is? It is 2, no? So here, that means L value is 2 here, and this value is 1. So from the LHL side, from 0.992, it is approaching to 0.9. After that, you will get 1. Here, what will happen? RHL means 1.1, 1.11, 1.111, 1.1112, like this. It will go on like these values. These from this side, they are approaching after 1.1, it is 1. So it depends on these delta values. Here also 2, no? So it will be from 1.9, 1.99, 1.999, 1.999, like this. So from left hand side, after 1.9, you will get 2. Here also 2.1, 2.11, 2.11, like this. So from this side, they'll approach to 2. From this side, they'll approach to 1. So whenever x is approaching to a, f of x is approaching to 2. So that is the concept of LHL and RHL. Means from two sides, they are approaching to each other for getting the values of when x tends to a and from x tends to L. That's why for solving the problems, we will use the concept of these two. And whenever these two values are same, LHL value is also 1 and also RHL value is also 1, then the limit of this function exists. Okay. So problem will be first question in the first unit is, they may ask the definition of the limit. After that, they will ask to show that whether the given function is existing the limit or not. The limit does exist or not, they will ask. So that will be the 3 marks question. For solving that problem, you should see LHL and RHL. If you are getting 1 and 1, or if you are getting 1 and minus 1. So LHL is not equals to RHL, so limit does not exist. So that is the concept of this one, okay? Next, if you go to the main here, here modulus is there, no? One thing you remember, for solving the problems, you will use some different formula will be there. Standard limit definition will not use. So whenever your condition is there, 0 less than mod x minus a less than delta is there. Okay, you might be knowing the modulus of a function. Modulus of x is equals to x if x is greater than or equals to 0. This is called as modulus. If you know the concept of this, you can solve the problems in continuity and limits and even differentiability. Okay. Modulus of a function of x is modulus x is equals to x. That is a positive value you will get if x is greater than or equals to 0. And it is equals to negative value if x is less than 0. You remember these two. So you can easily solve any problem. So here also, if we take modulus of x minus a means you will get 2. That is minus x minus a and also x plus a. So from this, you will get x belongs to a minus delta comma a plus delta. So if you add here, if you take inside x and here also x, you will get a minus delta and a plus delta. Why? Because here negative sign is there, here positive sign is there. So next we have the concept of RHL. RHL is equals to, we'll write it as limit x tends to a plus f of x equals to L. This here plus sign indicates it is right hand limit. And here you will have the limit values as a less than x less than a plus delta. Okay. So this is the value of x, that is x belongs to a comma a plus delta. And even working rule for RHL means while solving the problems, we'll write this as limit h tends to 0. H is always greater than 0. F of 0 plus h. So this thing you remember while solving the problems. Here h is nothing but whatever the delta is there. Delta is greater than 0. Always it is a positive number. So instead of delta, we are taking it as h. H is tending to 0. H is always greater than 0. In place of x, whatever the limit value is given in the problem, that one 0 plus h. It is the RHL. Same similarly, you can go to the LHL. LHL instead of plus sign, you will have the minus sign. So LHL is, it is limit extends to a minus. Here plus is there, no? Here you have to write minus f of x equals to L. And here the limit value will be a minus delta less than x less than a. Okay, that means x belongs to a minus delta comma a. And here when you go to the working rule, it is limit h tends to 0, h greater than 0, f of 0 minus h. So here plus sign will be there, here minus sign, here also minus, here plus. So when RHL value and LHL value both are equal, then limit exists and the function will have the value there. You will get some value. Okay. So remember these two concepts in for finding the limit of any function. So after that, you have the concept of continuity is there. So continuity, almost if you know the concept of limit, you can solve the problems for the continuity. Okay. So continuity means first condition is limit extends to a, f of x should exist. Okay. And the value you have to get is a finite. Some compulsory value you have to get. Instead of that indeterminate forms, you have to get some value. So if limit exists and finite, means first condition is this one for any function to be continuous. And second one is limit extends to a, f of x equals to f of a. So first one, here it is nothing but L, that is RHL is equal to LHL. When RHL is equals to LHL, some value will get either 0 or 1 or minus 1 like that. That is a finite concept. Exist means some values you are getting. So these two values should be equal to f of a. Please don't disturb the class. Okay. So here limit extends to a, f of x equals to f of a means you will get the first one is limit should exist and the value whatever you are getting, that should be any finite number. So in that means RHL and LHL value both should be equal. That is the first one. Second condition is limit extends to a, f of x should be equal to f of a. Means you can take here example, if limit extends to 1, x square plus 1 is there. Okay. So if you think RHL value for this is you got 2 and LHL value you got as 2. So what will be, this is the f of x, no? F of x equals to x square plus 1. So limit value is 1. So f of 1 is equals to 1 plus 1 equals to 2. That means f of value is 2. Here what is the limit value? 2 and 2 given f of 1 equals to 2. So these three values, if they are same, then the function is called as a continuous function. If any one of the value, if you got 2 and minus 2 means these two are not equal, but these two are equal. But the definition of continuity is RHL and LHL. First, they should satisfy the limit there. It should exist. If the limit here exists and that value is equals to the f of a value, then the function is called continuous function. Okay. And if you'll see the graph of the continuous function, if you take any function y equals to x square, you will have the diagram like this. Okay. So here from the pen point, you are not lifting the pen here and you are continuously drawing the graph. Whichever the functions we can draw without any gaps or jumps, that type of function is called as a continuous function. Okay. So if you have any here, if you have like these gaps or you're lifting up the pen, so such type of functions are called as discontinuous functions or removable continuity, it is also called. So okay. So continuous means you RHL, LHL and f of 1. These three values should be same. Then only the function f of x is called as a continuous function. Okay. Some properties are there in your textbook. So those properties you might be getting in the objective type of questions. Okay. This is even in continuous continuity concept, 2 or 3 theorems are there. Only in some cases they will ask those theorem for the 10 marks questions. So this is the concept about the unit 1, limits and continuity. Next, if we'll go to the second unit, it is the differentiability of functions. Differentiability of the function means, so already you know the concept of differentiation in the intermediate, you have that one. So how you got the differentiation? That is the main, some standard formula will be there for the differentiation. So we'll see that standard formula here. So here also, if we'll take any function f, it is mapping to a comma b to r. F comma b to r. So then you will have here at x equals to c. In place of x, we are substituting the c value. So limit x tends to c, f of x minus f of c by x minus c. This is equals to, this is the main, it is called as first principle of derivation. So this is the main formula for finding the derivative of any function. Limit x tends to c, f of x minus f of c by x minus c equals to f dash of c. Even this is called as the first principle of differentiation. So some questions, whichever will be asked for the 5 marks, they will give in the question itself. From the first principle, find the differentiation of the f of x equals to x square or sin x or cos x, like that they will ask. So this, from this you will get the 5 marks question, okay? And even we can write this one, whenever you convert into, working rule is there, no, for finding the problems, that is limit h tends to 0, h always greater than 0. In place of x, you substitute c plus h minus f of c by, here in the denominator also c plus h. So it is c plus h minus c. Both c will get cancelled. So it is equals to limit h tends to 0, f of c plus h minus f of c by h. So it is f dash of c plus h. Okay. So for solving the problems, we can use this formula. So it will be easy for us to solve the problems. So this is this one and this one, both are called as a first principle only. So direct, when the limit value is in the form of c, you can substitute and you can find the value. If for some problems, some complications will be there. So for such type of problems, you can use this one. Limit h tends to 0, f of c plus h minus f by h. So this is the main derivative formula. Here also, for showing any function, whether it is differentiable or not, is RHD. Here also RHD should be equal to LHD. If both values are same, then only the function is differentiable. Okay. So RHD, whatever the formula is there, that is f dash of RHD formula is this one only, same. Okay. Please don't disturb the class, mute your cell phone. LHD here, LHD is equals to f dash of c minus h. So if you'll see RHL and LHL, it is 0 plus h and 0 minus h. Here also same, similarly. It is equals to limit h tends to 0. See here, if we'll substitute here c minus h, what will happen? C will get cancelled in the denominator, minus h. Okay. So that is f of c minus h minus f of c by minus h. So this is the formula for LHD. So when RHD and LHD both values are same, then differentiability of that function exists, or else you can find the differentiation of that function. So the main formula is this one. You remember this as the first principle. Next, RHD and LHD. And here you will have in this unit, one theorem is there, only one theorem you have, that is every differentiable function is continuous. Okay. You understand here the meaning of this one. Every differentiable function is continuous, but the converse is not true. What is the converse? Every continuous function is not differentiable. Okay. If a function is differentiable, means it will be compulsory continuous function, but every continuous function will be not the differentiable function. You can take the example here. F of x equals to mod x will be there. This mod x is continuous, but it is not derivable. Okay. So like that, some functions will be there. They may be continuous, but they may not be differentiable. But if a function it is derivable, means compulsory, it will be continuous. You can take the example of constant function f of x equals to c, that will be continuous and also derivable. And if you see the identity function f of x equals to x, that is also continuous and derivable. C or x are all trigonometric functions, sin x, cos x, and everything. And e power x, exponential functions, and also logarithmic functions. So these, whatever the 5 category of functions are there, these functions are, they are continuous and also they are derivable. For this, the theorem is applicable. That is, every derivable is continuous. But for such type of whatever the functions will be there, they are only continuous, but they are not derivable. Okay. So after this, in this second unit, means only any one function. Now we have seen f of x equals to mod x. Like that, they'll give any problem and they'll ask you to find the continuity and differentiability both of that function. So that will be the 10 marks question. In second unit, you may have the chance of getting 10 marks question for the problems, whichever will be asked the continuity and also derivability. And in second unit, you have all the formulas, whichever you have studied in the intermediate, that is d by dx of x and also e power x and log x, sine, all 6 trigonometrics, and even sine inverse x, and also hyperbolic functions, sine hx, sine h inverse x. So these all formulas, how you got the answers for these formulas. So that proofs also given in your textbook. So if you know whatever the answers of this one, it's enough for the examination. Means they may be asking in the objective type, or else they may be asking the problems based on this one. So you should know all the formulas regarding of the differentiation. So this is the concept of the second unit. And next, if you'll go to the third unit is the methods of differentiation is there. So in methods of differentiation, you may have the chance of getting 5 marks. Hello, don't disturb in the between. Okay. In third unit, you have the special methods. So why these special methods are used? Because some functions are there which they can be only solved through the first principle of the derivative. Okay, so simple functions are there, means with the help of the derivation definition or derivation formula, you can solve them. But some problems will be there which they cannot be solved with the help of the first principle. So first principle means limit x tends to c, f of x minus f of c by x minus c, or else LHD and RHD. So such they are solved with the help of some methods. So here different 4 methods are there. So you can take the example of y equals to sine inverse of 2x by 1 plus x square, like this. So you can't substitute this value as f of x and f of minus c by x minus, in that case, RHD and LHD of this one, means sin x you can find, but here sine inverse of this value is there. So such type of problems you can solve with the help of the methods are there. So first method is here, substitution method is there. Second, logarithmic method is there. Next, third is parametric. And fourth one is implicit method. Implicit difference. So these 4 are the important ones. So any one question will get the further 5 marks question. So almost block 3 is of only 5 marks. 10 marks questions are from 1 and 2. Okay. So substitution method is nothing but whenever such type of problems are given, in place of this x, you can substitute either sin theta or cos theta or tan theta. But after substitution, it will be converted into any of the formula, whether it is a sin 2 theta or cos 2 theta or tan 2 theta. Then you easily can cancel out those 2 and you can easily find the sine inverse of that x value. Then you will get the method. Next, the concept for the logarithmic function is, so whenever you have function y equals to u to the power of v, here y equals to the power of v, who is also Okay. So second one is logarithm. So logarithm means why we will use the logarithmic concept of for solving the functions means the function will be in the form of u to the power of v. U to the power of v means here u is one function and v is also another function. So if you'll see the formulas for the d by dx of x to the power of n. X is here variable, n is here any number. So you have the formula for this one as n into x to the power of n minus 1. If a to the power of x is there, a to the power of x log a. Okay. So this is the number, this is the variable. So you have the differentiation formulas for x to the power of n and a to the power of x. But some functions will be there which is of the function to the power of function. That is sin x to the power of a power x or e power x like that, or log x to the power of sin x like that. Different two functions will be there. Here u and v are both are functions only. So such type of problems, they can be solved with the help of taking logarithm on both sides. And after taking logarithm, whatever the power will be there, it will be coming into the quotient. Then you can do the help of UV rule. Okay. Whoever is there, please mute your cell phone. You are disturbing the class.
Hello, good afternoon, ma'am.
Oh,
Hello,
please mute yourself.
ma'am. Mute everyone from your side.
So it is not accepting, no? Okay, now
Ma'am, you are the host. You can mute everyone.
Okay.
Okay, wait. Okay. So here for the function, if you have function to the power of function. So if you have the function to the power of function, then we can apply the logarithm on both sides and we can do the differentiation. Then the differentiation will be easy. Okay. So next third one is the parametric functions will be there. So parametric functions means third variable will be there instead of x and y. One more variable will be there. That will be t. So with the help of that is if any t variable means dx by dt we can find, and also dy by dt. If you divide both of them, you will get dy by dx. So that is the concept of the parametric differentiation. Next, implicit function means some functions will be there in that x variable or y variable will be there. Okay. And another instead of x and y, you may have sin x or cos x like that. Okay. So that is the concept of the fourth one. So in third unit, only 5 marks questions you will get. That is any method it will be given, and it is a almost second question in the 8 marks. 8 questions will be there. No, section A. In that second question or third question, you may get from the differentiation. Okay. So this is about the block 1. Next, if you see the block 2, it is the successive differentiation and partial differentiation. Okay. So these two, that is the main heading of that one, that is successive differentiation and partial differentiation. In that unit 4 is successive differentiation. So in this you have main about Leibniz theorem. Okay. Successive differentiation is nothing but, so any function is given. So if you have the function, so we write f of x equals y equals to f of x. Okay. So you know first order of this one is right? Dx. So if first order is of this one is dy by dx, and if we'll do one more differentiation, we'll write it as d square y by dx square, and so third order means d cube y by dx cube. If you go on this, we'll write d to the power of n of y by dx to the power of n. Okay. So this doing on differentiation again and again up to the nth term is called as a successive differentiation. Means you are going on up to whatever in the question, if he is asking d to the power of 4, that is a fourth order. If you find this, you have to find the fourth order of the differentiation. If fifth order is there, sixth order is there, or eighth order, in some cases they will even ask the nth order also. So it depends on the given problem. So such type of differentiation is called as a successive differentiation. And also remember that for the differentiation, we'll use dy by dx, or if the function is of y, we'll write it as y dash, y double dash, triple dash, y to the power of n. And also next, if it is in the form of f of x, f dash of x, f double dash of x, so on up to f to the power of n x. And even like this also we'll write. If you'll write here base 1, it is the first order. Next 2, second order. Next 3, so on up till y to the power of m. So these 4 types are the representation of the dy by dx. That is the derivative of any function. You can represent any in these any one form. Okay, in some problem, if they are given f of x, means they'll ask to find f dash of x. If y is there, means y dash. Or if like this y means, you can put here like this also, it is the first order. So this successive differentiation is mainly useful for finding the nth derivative of a function. Okay, so if you go on doing the derivation up to n terms, we can find the differentiation of any function. And also, so in the textbook, some standard forms are given for some some functions will be there, which are in the form of ax plus to the power of m, or 1 by ax plus b to the power of m, or sine ax plus b, or cos ax plus b, or e to the power of ax. Like this, different functions will be there. These are called as standard functions. Okay, they will be like this. So for that standard functions, you have the formulas are there in the textbook. Proof is also there, how you got that answer. Okay, so these whatever the formula, standard formulas are there for nth derivative of the functions, you may get for the 1 mark question, objective type, or anywhere in the objective type, they will get the questions. And if you know the answers, we can solve any sort of problems with the help of finding the nth derivative. Okay, so nth derivative is from the standard form, you can find the nth derivative of any given function. So that is one concept. It is for 10 marks you have. Okay, so if you'll see there, you may get the 10 marks question for the finding the nth derivative of any function. And if you'll go to in this only nth derivative, second concept is rational functions will be also there, like this. I have told you 1 by ax plus b to the power of m. For that also you have problems are there, and also for trigonometric functions like this also you have the formulas. And in this only next one is successive differentiation and Leibniz theorem is there. So why we use Leibniz theorem here means, so only single function is given, only one, that is whether it is a sin x or cos x or e power x or log x or anything. So if only single function is there, we can use directly this nth derivative form, that is going on doing the differentiation, and you can find the value. But the problem arises when there are 2 functions at a time. That is, if the function you have in the form of x square and also sin x, or e power x and sin x. So when 2 functions are there as a product, then we can't use this nth derivative formulas here. That means x to the power of, you will have one formula, and sin x you have another formula. So 2 formulas at a time you can't club and you can solve the problem. Okay, so for such type of functions, to solve these type of problems, Leibniz theorem is used. So Leibniz theorem, you have one formula is there. With the help of that formula, you can solve those functions if you have the 2 functions given in any f of x. So that Leibniz theorem is, we can write like this: d to the power of n by dx to the power of n of uv. Here u is one function, v is also another function. So this is written even as uv of n. That is nth order of these 2 functions. So it is equals to nc0 un v plus nc1 un minus 1 v1 plus nc2 u n minus 2 v2. So on up till ncn u vn. Okay. So this is the expansion of the binomial expansion is there, no? So that is in the form of that one nc0 un v nc1. So you are expanding these two. That means here this is the u function and this is the v function. So if he is asking in the question to find un of 4, that is uv of 4 means here 4c0 4 that is 4n, that is un means u4 v plus 4c1 u3 v1 4c2 u2 v2. Okay, so here 4c4 u and next v4 you will get. That means it is the fourth order. For fourth order we are finding the differentiation of the two functions at a time. If you substitute the values here, you can get easily the answers for this one. Okay, so here this question or that first successive differentiation, any one will be the 10 marks question, and this is the 10A question you will get from this one, block 2. 10A compulsory, either with the help of the Leibniz theorem or with the help of the successive differentiation, any one concept, you will get the 10 marks question here. Okay, so after that, this is the 5th unit, no? So these two are important here. This is the 4th unit. Next we have the 5th unit is there. 5th unit is the partial differentiation. And in partial, how you have a successive differentiation and one theorem is there. Similarly, 5th unit also partial differentiation is there. Another theorem is there, that is the Euler's theorem is there. Okay. Okay, your Euler's theorem you have for solving the partial differentiation. Okay, so partial differentiation is here nothing but you know the concept of normal differentiation. If any function is given, y is equals to x square plus y square. Okay, so for this one, we'll find dy by dx as like this. Dy by dx is equals to x square differentiation is 2x into dx by dx. Here we are talking about the unit 5. Okay, so x square means it is 2x. That is, it is in the form of n into x to the power of n minus 1. If you substitute there, you will get x square as 2x. 2x d by dx by dx. Why? Because with respect for variable x, it is dx, and we are doing with respect of x. That's why we'll write dx by dx, and this value is 1. That's why whenever we'll do the differentiation of variable x, we'll not write dx by dx. Why? Because it's 1. So we'll take it as only 2x. But when it is compared to y square, it is 2y into you are doing respect of y.
So it is dy by dx.
You are able to see the screen.
Yes, ma'am.
Okay, so it is dy by dx. So that means it is with respect of x square is 2x and 2y is dy by dx.
Dx.
So it is a normal differentiation. When we'll go to the partial differentiation, so we'll take another variable, that is, it is as z or t or anything we can take. So z is equals to, if we'll take same x square plus y square, partial differentiation, it is d, no, it is represented as dou. Dou y by dou x. Sorry, here dou, here function is z, no, so dou z by dou x. And the partial differentiation is that we'll do here the variables separately. That means for variable x we'll do one differentiation, for variable y we'll do the another differentiation. So dou z by dou x is equals to, here x square is 2x, but whatever the y square is there, that is treated as a constant, that is c. So constant differentiation is what? 0. So only with respect of x, if you do the differentiation, you are getting it as 2x and y square is 0. So when you'll do one more time differentiation, that is dou z by dou y with respect of y, this is treated as constant. So it is 0 plus 2y. So this is the concept of partial differentiation. So how many way, if you have here one more, t square is there. That means third time you have to do dou z by dou t. It is equals to 2t. So this is the main. If you see the partial only differentiation, at a time you can do any variables, any number of variables at a time you can do the differentiation. But when we are going to the partial differentiation, with respect to of what variable you are doing, that variable only you have to do the differentiation. Okay. So this is the main concept. And even if you have your z or maybe function f also given in the question. So only first order means we'll write like this fx. If you'll take two order, second order means we'll write f to the base xx or yy if you are doing with respect to of yy. So if we'll do the mixed one, that is with respect to of x, y variable also we can see. So this is equals to yx. If both the variables you have, if you will get the same value, you can take this one. Okay. So but partial differentiation like this, it is represented to the function base x. Here also xx means it is second order. Means dou square also you can use, but it is the simple form for solving the problems. So this is the concept of partial differentiation. So in the partial differentiation, you have compulsory 5 marks question. You will get any one, only 5 marks in this part. And second part, you have the Euler's theorem is there. So Euler's theorem is nothing but so before the concept of Euler's theorem, you have the homogeneous function is there. Homogeneous function means so for the function in the examination, they will ask even the what is the degree of the homogeneous function. It will be in the formula like this: f of x comma y equals to a naught x to the power of n plus a1 x to the power of n minus 1 y plus a2 x to the power of n minus 2 y square, so on like this, a to the power of n x to the power y. Okay, x will be not 0. So here two functions at a time, that means two variables you are taking. So if you take single means function f of x equals to will write. So if you are taking the two variables at a time, then f of x comma y equals to a naught means you are expanding that one. So for this one, we can find the degree of the homogeneous function. That is a 1 mark question you will have in the examination. If you see f of x comma y equals to given in the question like this, x square plus y square. For solving the problems, you can take like this, if instead of x, you write lambda x, lambda y. So it will be lambda square x square plus lambda square y square. If you take lambda square outside, it is x square plus y square. So here, whatever this part you have the degree, that is called as a degree of the homogeneous function. So here the degree is 2. And what is this? This is in the form of f of x comma y. Okay. Whenever like this, you can write that function, that type of function is called as a homogeneous function. So this one, when you write it in the form of homogeneous function, it will be in the form of like this: x to the power of n pi of y by x. X to the power of n pi of y by x. From this part, you take out x to the power of n outside. What will happen? Y by x, y square by x square. Here y cube by x cube. Last you will get y by x to the power of n. So whenever you can take x power n common like this form, or if you take y to the power of n common, it will be in the form of x by form. So when a given function you can write in these two forms, then that function is called as a homogeneous function. Here if you take in the problem, if you get here 2 or 3, anything, that is called as a degree of the homogeneous function. If you have any complicate of this concept for finding the problems, you can go with the lambda x in place of x and lambda. In place of x, you substitute lambda x and also lambda y. Okay. So this is about only 5 marks question you will get. And about the Euler's theorem is that Euler's theorem is x into dou z by dou x plus y into dou z by dou y equals to nz. This formula you have to remember. So even for objective type also, they will ask the questions. So x into dou z by dou x plus y into dou z by dou y equals to nz. And on this Euler's theorem, compulsory 5 marks problem you will get. Okay. So one function will be given. For that function, you have to find dou z by dou x and dou z by dou y, and you have to multiply this with x and this with y, and you have to add them. Then it should be equal to n into z. So n into z means here n is the degree of the homogeneous function. Okay. So this is the concept about unit 5. So these two only concepts are there in this. Next, if you'll go, 60 unit is there in the block 2. 60 unit is a very important unit. Already I have told in the 4th unit, you will get 1 10 marks question. And in the 6th unit, you will get 1 10 marks question. So 5 marks question will be from the unit 5 only. So here 1 10 marks you will get, that is a 10B. So unit 6 is the mean value theorems. So mean value theorems, first one is the Rolle's mean value theorem. Next, second one is the Lagrange's mean value theorem. Third one is the Cauchy mean value theorem. Okay. So in the examination, they may ask the definition, that is a statement of the theorem and also proof of the theorem. That is also 1 10 marks question, or else only problems will be given for the Rolle's and Lagrange's and this one. Okay. So Rolle's mean value theorem is only one function will be there. That is a function f will be there. It will be mapping from A, B to R such that f is continuous and f is derivable. This is continuous on closed interval a comma b, and this is derivable on open interval a comma b. Then there exists c belongs to a comma b such that f dash of c equals to 0. See, a third condition will be also there. This is the first, this is the second, and third one is f of a equals to f of b. This is the important in Rolle's mean value theorem. First one is the given function should be continuous and it should be derivable. Third one is f of a and f of b means these interval values. If they are equal, then one number, that is c, will be exist in open interval a comma b such that f dash of c equals to 0. This is the statements of mean value theorem. Okay. Next, you have the Lagrange's mean value theorem. Lagrange's mean value theorem is same. These two conditions are same, but this f of a and f of b will be not equal. C belongs to a comma b such that f of b minus f of a equals to by b minus a equals to f dash of c. Okay, this is the statement of Lagrange's. And if we go to the Cauchy's mean value theorem, for Cauchy's you will have the two functions will be there. Two functions means f is one function, another function is g a comma b to r. So here f comma g is continuous, f comma g is derivable, and third one is g dash of x should not be equal to 0, and also c belongs to a comma b such that f of b minus f of a by g of b minus g of a equals to f dash of c by g dash of c. So this is the Cauchy's theorem. Here two functions will be there, f and g. So if you know these statements, easily you can solve the theorems and also you can solve the problems. So only they may ask a statement and one problem will be given. That problem, if you solve, it's enough. Okay. So this is the one compulsory 10 marks question in 6th unit. So 4th and 6th unit 10 marks question, and 5th unit is the only 5 marks questions you will get in that. Okay. Tomorrow we'll see the block 3 and block 4. Just a light introduction I will give. After that we'll go to the unit 1. Okay. Okay, students, bye.
Madam.